Have you ever wanted your circuit to tick like a broken clock or sound like a secret Morse code? Well, guess what? With just a 555 timer and a few tweaks, you can make your project click unevenly on purpose, and it's way cooler than it sounds. Hey guys, in this video, I'll demonstrate how to make an uneven click circuit using a 555 timer. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 2 alligator clips, 5 jumper wires, one 47,000 ohm resistor, one N4148 fast switching diode, 2 10 microfarad capacitors, one 555 timer IC, a battery holder with 4 AA batteries for the power source, one 5-watt speaker, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Starting from the top left is pin 1, which is ground or the ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and astable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Start by placing the 555 timer IC onto the breadboard. Remember, the pins are numbered counterclockwise, starting from the top left. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Use a jumper wire to connect pin 4 or reset to pin 8 or VCC. Insert a 10 microfarad capacitor into pin 2 or trigger in the negative rail. The anode is in pin 2. Insert a 10 microfarad capacitor into pin 3 or output in a few rows below the 555 timer. The anode is in pin 3. Bend the ends of a 47 kilo ohm resistor. Insert the 47 kilo ohm resistor into pin 3 or output in pin 6 or threshold. Bend the ends of a 1N4148 fast switching diode. Insert the diode into pin 3 or output in pin 5 or control. Insert a jumper wire into the same row as the capacitor. Attach the other end of the jumper wire to an alligator clip. Insert a jumper wire into the negative rail. Attach the other end of the jumper wire to an alligator clip. Attach the other ends of the alligator clips to the 5-watt speaker. It's time to connect the power supply. Connect the positive lead of the battery holder to the positive rail. Connect the negative lead of the battery holder to the negative rail. We have successfully completed the circuit. Let's dive into the circuit and break it down step by step. This circuit uses a 555 timer IC configured in a stable mode to generate an audible clicking sound through a speaker. However, unlike regular metronome circuits that produce even rhythmic pulses, this circuit creates asymmetrical or uneven time intervals between each click. The 555 timer is powered by a 6-volt battery connected to pin 8 or VCC, with pin 1 connected to ground. Pin 2 or trigger and pin 6 or threshold are tied together and connected to one side of a 10 microfarad capacitor. This capacitor charges and discharges periodically, controlling the high and low intervals of the 555's output, or pin 3. The 47 kilo ohm resistor is connected between pin 3 or output and pin 6 or threshold. The output from pin 3 is connected to a 1N4148 fast switching diode, which then charges a second 10 microfarad capacitor. This capacitor is placed in series with a 5-watt speaker. The diode only allows current to flow during the positive half of the output waveform, so the speaker only activates when pin 3 goes high. The charge and discharge paths of the capacitor and the diode are unbalanced, which means the speaker receives uneven pulses, some quick, some slightly delayed, resulting in the distinctive clicking sound. The diode plays a key role in shaping the pulse pattern. It ensures the capacitor charges in one direction, introducing asymmetry in how the capacitor and speaker respond to the timer's output. Each pulse causes the capacitor to momentarily dump charge into the speaker, producing a click. Since the charge and discharge timing of the capacitor connected to pin 6 is determined by both the resistor and internal behavior of the 555, the duty cycle is naturally skewed. This combination of unbalanced charging times and directional current through the diode results in the uneven clicks. That unevenness gives it a unique and interesting sonic character, perfect for sound experimentation or quirky alarm systems. I hope this video has shown you how to make an uneven click circuit with a 555 timer IC. Want to upgrade your clicks with a bird chirp? Check out my other video where I show you how to make a bird sound doorbell using a 555 timer IC. I've linked the video in the description. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Don't miss it. Click the link in the description to get yours. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.